Colonel K.V. Kuber, Director Aerospace and Defence, Ernst & Young, General Ravi Arora, General Bhatia, distinguished chairs, Air Marshal S.P. Wagle, Vayu Medal, Deputy Chief of Integrated Defence Staff, Dr. Seema Vinayak, General Sanjay Verma, Dr. G. Madhusudan Reddy, Commander Dr. Bhushan Devan, all distinguished panelists, distinguished members of CENJOWS, scientists, captains of the industry, all participants, ladies and gentlemen. I am General Sunil Srivastava. I am Director, Center for Joint Warfare Studies, and on behalf of CENJOWS, I welcome everyone to today's webinar on advanced materials, which CENJOWS is co-hosting with the Indian Military Review, represented by its CEO, General Arora. So advanced materials, as we all are aware, are critical for national security since they find use almost everywhere, be it aeroplanes, warships, missiles, vehicles, energy generation and storage, computers, advanced electronics, medicine alike. But India imports nearly about $2 billion worth of critical and advanced materials, which by value, 37% of this is on special steels, despite India being the second largest producer of steel. And another 37% by value is on nickel, cobalt, and iron-based superalloys for turbines, nuclear reactors, and rocket engines. And our demand for titanium alloys itself is projected to be over 5,200 tons by 2025. And like close to 60% of that will be for aerospace and defense only. And the Indian semiconductor market is forecast to be over almost $30 billion by 2025. And India imports for refining its steel about 300,000 tons of ferrosilicon per year. And just to share with you all, is that the prices of ferrosilicon were ranging from 55,000 rupees per ton pre-COVID. And during COVID, they shot up to nearly 90,000 rupees per ton. So that's the kind of impact that disruptions have. But materials have been KRA in the recent past, and TIFAC, that is Technical Information Forecasting and Assessment Council, had published a seminal work, Technical Roadmap, as part of Technology Vision 2035 way back in 2016. And in the face of the geoeconomic and geopolitical uncertainties, there's an urgent need to enhance self-reliance, Atmanirbharta, in materials, to address the strategic vulnerability, which is a mission for armed forces and strategic communities, not just for India, but all over the world. And rightfully, DPEPP 2020 envisions a turnover of $25 billion and exports of $5 billion in defense production itself by 2025. And the DAP 2020 as well as the DPEPP 2020 have accordingly stipulated a slew of measures as regards alloys and special material. And this February, during the Aero India show, Dr. Reddy, where he was participating, had exhorted Dr. Ajay Kumar, the Defense Secretary, to finalize the draft policy on materials, which had been put together by a dedicated team of experts. However, just policy interventions will not be enough. All of that needs to be translated into action in mission mode by all stakeholders. And we need to leverage our strengths, working collaboratively across ministries, across departments, public and private industries, R&D establishments, as also with our partners abroad to realize the supply chain resilience and self-reliance in advanced materials. The LCA and other choices being made recently are clearly steps in that direction. However, the fact remains that we cannot use indigenous materials in critical foreign designed defense equipment. And where we can, the cost of Indian source materials is nearly 25% higher. So therefore, we must charter strategies with a time-bound roadmap of short-term actions like stockpiling, diversification of imports, etc., and mid and long-term strategies to acquire related technologies through consortiums and joint ventures with OEMs setting up material industries in India, leverage offset obligations, increase process efficiencies at all levels of the supply chain, from mining to testing to certification, also including recycling and reprocessing of materials. And we must incentivize private participation and find alternatives through robust industry-funded R&D. Now, today we propose to get a rounded perspective during specific sessions on aerospace materials, the first session, the materials for missiles, guns, and warships. The third one will be on additive manufacturing and 3D printing. And the last and the final one on smart and future materials. And we are fortunate to have all these stakeholders and domain experts together on this platform to share their perspectives, concerns, as also strategies to synergize our collective endeavor to achieve self-reliance in strategic materials for our current and future needs. India has demonstrated, its capabilities and resolve in space, as also in nuclear technology. So we are confident that aerospace and defense will not be any exception. And DMRL and Midhani have already made some very path-breaking achievements about which we'll be learning shortly, and much more that will be shared by the captains of the industry. So Dr. Satish Reddy will be joining us a while later. Meanwhile, I want to introduce to you Colonel K.V. Kuber, as I said, Director, Defence and Aerospace, Ernst & Young, who will be giving us the industry perspective. Colonel Kuber is an alumnus of the National Defence Academy, where he later served as an instructor, training future leaders. He has had a successful career spanning almost 3 decades in the Army, where he specialized in electronic warfare and commanded electronic warfare resources in conventional and counterinsurgency operations. He has also played a very pivotal role as Director, Capital Acquisition Programs in the Ministry of Defence from 2005 to 2009, 4 years. And he was the architect of the offset policy and set up the Defence Offset Felicitation Agency in 2005. He was a pioneer in many ways. And he's also been the advisor to NSIC, Ministry of MSME, from 2012 to 14. And he has been invited by a host of companies abroad like Embraer, Raytheon, Rafale, Israel, and also by the government of Australia to share his thoughts on issues related to defense procurement. He was also an advisor to DRDO for 2014 to 15 for technology transfers and offsets. He was a member of the National Committee of Experts for formulation of DPP 2016. He founded the Sughosh Advisory in 2017 and Sughosh Media in 2018 with a core focus on MSMEs and Defense Insights, which is an e-magazine I'm sure most of you are familiar with. So he is an active member of FICCI, SOCHAM, and PhD chambers. So over to you, Colonel Kuber, for your thoughts on the subject.
Thank you, sir. General Srivastav, General Ravi Arora, distinguished delegates, senior officers present, ladies and gentlemen. We've been talking about a 5 trillion economy. We've been talking about Atmanirbharta in defense. We've been highlighting the importance of IDDM and how Indian companies should enhance indigenous content in defense procurement. And this is where I go with the theme line to say, strategic raw materials Atmanirbharta ka bunyad hai. Strategic raw materials are the bedrock of Atmanirbharta. If we ever forget this mantra, then we'll have to revisit and understand that more than 20 to 26% of any platform is all about raw materials. As a recent example, I can tell you, during the COVID times, the United States of America and many other countries stopped supplying raw materials linked with pharma, and they generally cut off uh, the supply of raw materials outside the countries. This has happened in strategic raw materials, which affect sectors like defense, nuclear energy in the past. It is likely to happen in the future. You may make the Tejas Mark II. We may make the Tejas Mark III. We may go on to the AMCA. We may go on to many super efficient missiles. But if somebody were to cut off that critical raw material, our production could come to a standstill. That is the importance of strategic raw materials, and therefore I think it occupies a pride of place while we discuss Atmanirbharta. Ladies and gentlemen, India is likely to be among the top 3 military powers by 2025, along with US and China, with a projected defense outlay of more than $655 billion. It is likely to surpass Japan, Australia, South Korea, and so many other countries by developing sizable and technically advanced forces, including ocean-going navies, capable of delivering and enduring maritime presence both regionally and further afield, according to a study titled Global Strategic Trends. When I just see Israel, more than 70% of the military industrial output, it is directed towards export markets, and it's eyeing an increase in the sales in Vietnam, Azerbaijan, Brazil, Poland. South Korea, the defense industry was based on US technology in the 80s. Slowly they have gone into their own Atmanirbharta and gone, I mean, some platforms like the K2, the main battle tank, the K21 IFV, the K9 howitzer, the FA-50 jet aircraft have all been developed domestically, and they did have a focus on raw materials. We know how the status of Indian defense industry, what was it at the time of independence, how it moved in 1991 with the industrial policy, and 2001 with the press notes, and then we have gone from a 0 to about 74% FDI in automatic route today. There are more than 550 countries with industrial licenses. We are talking about export promotions. We are talking about defense enhancement, defense production enhancement. Today, the defense production is around 60,000 crores. We are looking at 1,35,000 crores next about 3-4 years. We are looking at export of 35,000 crores. We have an export ambition to produce, and that ambition can truly be fulfilled only when we address the fundamental issue which is at the bottom of the pyramid, and that is the raw materials. You can export only what you own. You cannot export something that you don't own. If you don't own raw materials and at critical time it is not made available to you, well, I think we are going to remain where we are, and our ambition may get curtailed, and therefore it's important that we address this critical issue. There are major challenges in this. The critical and strategic raw materials are controlled by the OEMs and international suppliers, the certifications, the restrictions on indigenous versus imported equipment, the technology know-how. Sourcing from traders is always a trade-off between cost and volume. Certifications are the norm, and the certifications are normally done by the OEM, and therefore we need to get into that field, which will be very, very important, because by the time we certify the raw material, the development phase would have been over, and therefore the production agency will be forced to import the raw material, because our raw material would not be certified and nobody will take a chance over there while we do while we go into the production. Giving an order for LCA is one aspect. Encouraging DRDO LCA to source local raw materials is another. And production of these raw materials, certification grade, is a third dimension. Volumes preclude cost, and I'll come to this in a while. So the General Srivastav did mention about the DAP. It highlighted that the indigenous availability of high-end military materials and special alloys is an important facet of self-reliance and defense sector. This is what the DAP says, and that's damn good. So does that. Is on development of indigenous capability in the segment has not really taken off. We have not been able to promote military materials known to be available in our own country. Acquisition projects other than buy global for platform and major equipment with substantial material component should be examined by the SHQs at the RFI stage, is what the DAP states. And it also states that you should ascertain the feasibility of using and rewarding the use of indigenous materials. We are still awaiting a program which is going to actually do this, and we are awaiting the focus that that the DAP has provided, and the implementation to this focus that the armed forces have taken up. And therefore we are looking at phased developments of materials by platform manufacturers and R&D establishments. We are looking at inclusion of technology transfers for manufacture and validation of materials in the licensed manufacturing projects by the production agencies or suitable Indian material manufacturers. We are seeking and prioritizing or promoting transfer of technologies for military materials against offsets, and taking up make or technology development funded projects for the development of materials. So I think we are waiting for these things to happen. So para 12 of the DAP is pretty good, and it says, you know, how it gives out the reason, it gives out a suggested methodology. If there is a lack of knowledge, then it says you define the requirement by use of the indigenous materials and or incentivize. Then it talks about the cost of indigenous materials and gives as to how you can provide an incentivization up to 15% of the cost. And if it is not validated, it says provide incentivization up to 25% of the cost of the material subject to a maximum ceiling of 1%. So while the DAP states BNE on aero engines and fab, which almost makes it mandatory to be procured from indigenous sources, the same has not been said for military materials. And I think maybe one could say that classifying military materials as a BNE is an option, and is a very good option to promote the use of indigenous raw materials. However, consider a material which is rare earth and not available in the country and imported from a commercially viable option, then it cannot be declared as BNE for obvious reasons. So we need to address these issues, and we should say that, you know, where the material is available in India but not used due to lack of knowledge, ease of import may be declared as a BNE. So these are issues that we need to see. And I just thought, you know, there are some despite the manufacturing capability that's existing in the country, there are some constraints due to which we source it. That is economies of scales, non-acceptance of equivalent indigenously developed materials by the users, delay in the development of certification process, non-availability of technical specifications, and higher number of components and raw materials are imported from OEM approved foreign vendors, which constitute a major part of import, but it's not reflected in the materials import. So we picked up some data, the global demand. Also, he gave us some data, and he talked about silicon. Now, if there is a global demand, we are talking about, if I pick up, the export data from the Ministry of Commerce, and there is an import of approximately 14,000 crores that we are doing in materials in super alloys, high-end aluminum alloys, titanium alloys, special steels, copper and Cupro-nickel, composite materials, carbon fiber, for example, tungsten, ceramics. And by the ITCHS code that we tried to map, the nickel super alloy like bars, it is close to about 400-500 crores. And of course, we have the data for the rest of the things too. I'm not going into that, but just to highlight that we are actually importing a lot, and there is a need for a very clear focus at this stage that we need to address and pin it down, because the growing influence of the nation in the Indian Ocean region is an eyesore for many, and there would be forces that would work against us all the time and try to identify those vulnerabilities that may actually affect our strategic production, strategic thinking, and our strategic progress. So there are some issues that have been raised by the industry, such as non-availability of technical specifications, cost of material procured from Indian suppliers is about 25% higher. Jal Srivastava also mentioned this. Issues with compliance to international standards, and the material has to be certified, and the product has to be made out of that material which has to be certified. So specifications that the Indian defense equipment manufacturer demand from organizations such as Midani are very stringent. So we need to also try and encourage our own Midanis, our own Star Wires, our own companies which are today producing all this. Nalco. I mean, we have almost the best aluminum available in the country. A little bit of an incremental investment by Nalco, and you will see that the ABG group will come out with the best aluminum worldwide supply. So I think these are the initiatives that we need to actually push forward. When I see some of the upcoming missile systems such as LRSAM, SR, ADGM, we have just seen the DCPP program on the VLSR-SAM, the vertically launched, where DRDO has invited the private industry, and they've got a tremendous response. And that is the path in which DRDO is moving forward in engaging with the Indian industry. The Nirbhay cruise missiles, and in the aero system, some things like AMCA, the Ghatak UAVs, engines, the dry engines, the rotary UAVs, Man, Alpha, the sensors, radars, submarines. So when we see all this, if we do not have the right raw material, if we do not have the qualified and certified raw materials at the right time, we may not be able to reach our targets. And therefore, if we have a target, if we are looking at those 1,75,000 crores, if we are looking at that 35,000 crores, if we are looking at that $5 trillion economy, then I think we need to actually look more deep, such as stealth materials, the materials for sensors, soft magnetics for electric aircrafts, high nitrogen and non-structured steel for armor applications, graphene, carbon nanotubes as materials for aircraft wings, CFRP, composites, fiber reinforced polymers, advanced, and the list goes on. So there are some carbon composites, there are some DMRL technologies that have been developed, such as the tungsten extraction technologies and the next generation explosive reactive armor, the composite armors, and between DMRL and Midani, they function as twin sisters, and therefore there is a lot of synergy. And if the synergy can be improved by also including the private sector at large, then we would find that knowledge base would increase, the production base would increase, and the investment base could increase, and therefore since the private industry can be a wealth creator, they can also be a very sizable investor at critical junctures, and not only wait for the government funding for each of these projects. And therefore, in this synergistic collaborative mode, we'll be able to achieve much more than what we are thinking at. There are some very good achievements by Bidani in the recent past, such as the materials for high pressure combustion disk, unique titanium castings, nickel and titanium alloys, and HAL did sign an MOU for development and production of composite raw materials in Aero India, mainly in the form of PPEG used in platforms for LCA, LH, LCH, LUH are all imported today. And there is no equivalent proven Indian qualified supplier for various types of prepegs, the carbon, aramid, glass types, etc., type application. And therefore, things like even the development of the Kaveri engine, which has brought Bidani, DMRL, GTRE, industry, certificate, all of them have come together, certification agencies, in such a synergistic manner, which has led to the design of 12 materials that are certified. I think we just need to replicate the successes that we have, like we say in the armed forces, always reinforce the success. And when we have a success like this, we just need to reinforce, we just need to repetitively do it across various other subdisciplines in the raw materials and achieve what we need to achieve. The developed materials such as ultra high strength, high fracture toughness, low alloy steel, DMR 1700, which is used in missiles. Small issues like welding of these materials have been dealt with, and now we know that only DMR 1700 shall be used in missiles. And these are the things that actually encourages us. So we are looking at the domestic consumption of aerospace materials to increase from the present low levels of 2% of the global demand, and the Defence Production and Export Promotion Policy has identified this to be critical for self-reliance, and also they are vital as raw materials for other 12 technologies listed in the DPEPP. The DAP has highlighted this. Additive manufacturing is being adopted widely as it offers flexibility. You must be seeing even now ARD has issued a RFI for the ASME, the 9mm ASME, and this is going to be developed in a 3D in an additive manufacturing mode. And these are certain very, very good things that are happening. While this is happening, well, I think here the focus, if we address the fundamentals in raw materials, I think we would do a great job. I was just seeing that there is a European Raw Materials Alliance, which is securing access to sustainable raw materials, advanced materials, and industrial processing know-how for the EU industrial ecosystems. I think we need to develop certain organizations of that standard. And EU recently released a study on critical raw materials for strategic technologies and sectors. This study looks at the supply chains of 9 technologies in 3 strategic sectors: renewable energy, e-mobility, defense, and aerospace. Well, ladies and gentlemen, I want to rest my case here and say again that military raw materials, Atmanirbharta ka bunyad hai. We need to understand this, we need to focus on this, we need to invest in this, and we need to take it forward so that our Atmanirbharta desire and ambition can be fulfilled in the times to come. Thank you very much. Jai Hind.
Thank you so much, Karan Kuber, for that very well-rounded perspective from the industry side, and supported by a lot of authentic facts and figures, which should make us take a very clear-eyed view towards what our vision is, where we are headed, what our envisaged requirements are, what disruptive challenges can occur, and as to what are the gap areas. You have flagged a whole lot of them. At the same time, while you acknowledged what has been done in an evolutionary manner over the last 2-3 decades as far as defense production is concerned, and you also mentioned as to how a lot of synergy between industry, MSMEs, and the defense research establishments is already happening. DMRL and Milani are a case in point. We flagged that. So we'll be, as we go through today's other sessions, we'll be hearing more about all these challenges, about certification, about getting JVs, about getting how we can get technology transfer, and a host of other things that need to be addressed. So thank you so much, Karan Kuber. And I now welcome Dr. Satish Reddy, Secretary, Department of Defense, Research and Development, as also Chairman DRDO, who has taken time out from his busy schedule. We fully acknowledge that, sir. While Dr. Reddy actually needs no introduction, leading aerospace scientist of great repute, renowned not just in India and abroad. He has been honored by awards which have been given by United States to nobody outside United States but him. So although he needs no introduction, but yet in acknowledgement of his contributions in this defense production and research and development, I would just like to walk everybody through a few of his achievements. He has a vast experience in navigation and avionics design for missile systems and aerospace applications like the G3INS for ALH, inertial navigation system for ships and submarines. He has spearheaded countless projects in aerospace defense technologies. As director RCI, he had led the development of seekers and integrated avionics modules. As director of missiles and strategic systems, he spearheaded development of BMD missiles and a host of all other missiles that you can think of, and as also the long-range guided bomb. He has been instrumental in development of air defense systems, like some of which Karan Kuber was just mentioning: Astra, Akash, LRSAM, MRSAM, QRSAM, and several path-breaking achievements like ATAGs and the anti-radiation missiles and smart airfield weapons, smart bombs, and missiles-assisted torpedo systems owe their success to his vision. India's well-known ASAT mission Shakti was successfully executed under his watch, and he's also driving innovation in cutting-edge research in hypersonic and quantum technologies. So we couldn't have found a better person to give the inaugural address and give us the guidelines and his thoughts on how we should be exploring our pathways. So over to you, sir.
Thank you. Very good morning. General Sunil Srivatsav, the Director, Center for Joint Warfare Studies, and the host of eminent personalities who are participating in this very important webinar, Advanced Materials for Defense and Aerospace. Firstly, let me congratulate the CENJOWS for organizing on this very specific topic. It is very, very important. In fact, when I took over as a scientific advisor to Raksha Mantri, the first thing what I did is I actually conducted a workshop on this subject with Honorable Raksha Mantri, that time the Manohar Parikar, who himself happens to be a metallurgist from IIT Mumbai, has been all through in the workshop, and later that he constituted a committee to look into the strategic materials and how we become self-sufficient in that. In fact, I like to mention that Dr. Baldev Raj, famous scientist who has worked in these areas and known for his excellency in this area and tremendously contributed to the nation, was the chairman of this committee. That today is very important that we should remember him. Today happens to be his Padma Shri Baldev Raj birth anniversary. In fact, unfortunately, we lost him, a famous scientist, but then his works and his report, what he has submitted to the government, are very, very important and very critical. In fact, I strongly believe if a nation has to become real self-reliant and then has to prosper in a big way, two things are very, very important. One is you becoming self-reliant and have enough stocks of material, particularly materials which are critical, which are strategic in nature. This is the first. Second is manufacturing. To have an innovative manufacturing technology available within any country. Otherwise, you won't be able to compete in the world and you won't be able to sell across the world. But none other than United States of America identified almost about 42 areas of innovative manufacturing, started building institutes in each and every area where you should be able to come up with very innovative technologies in the manufacturing, actually reduces our cost, time, power, waste, whatnot, green technologies and everything. So that's how I say that materials and manufacturing are very, very important. Now, when we say materials, we should actually look into multiple things. First thing is, what are the natural resources available within the country? We should have a complete picture and survey of these natural resources which are required, which are available in the country. We have the whole picture available with you, and what is your consumption, what is your requirement, including what is the requirement within the country and what you need to export as a finished product, and look into those requirements, and then how to exploit these available resources, how do you mine it, and how do you process it is one important thing. Now, if it is not available and your requirement, what you have, and will not be met from this natural resources available in the country, how do we actually fill this gap? Is another strategy as a nation we need to have. We do a lot of mining activities across the globe, find out which are all the countries where these natural resources are available, and how do you get that, and taking steps to ensure that an Indian company is able to do the mining there, and then you are getting the return. I'll give you an example in this area. Let's say, I think Kalna Kuber gave a detailed spectrum of everything happening in the country and what is it and all that materials. So he was also mentioning about rare earths. The rare earths, particularly natural resources available in the country, whether it is along the beaches of the east coast or some other places like Rajasthan and the things like that. That is one thing. But then when you look at the rare earths, when you look at our neighbor friend, the type of natural resources available there and what are available here, we just cannot compare. So what is our strategy? How do we go ahead? Where do we try to get this material? What is our requirement? One, no, you are not able to get, you are not able to do any mining. Then how do we get, how do you buy, and how do you stockpile so that you are safe at least next 50 years, 100 years? This is the long-term plan what a nation need to have in these type of core materials what we need in the country. This is one step. Second one is the processing technologies. So what are the processing technologies required, and do we have today? How do we need to develop? How do we actually fund the R&D? How do you make the R&D progress and various laboratories in the country across the departments? And how do we ensure that they're all working in a synergetic manner and come out with the necessary processing technologies? To again identify what are all the processing technologies which are required for what type of a material, what type of alloys and various things what is required is another important thing. But definitely look at it and try to see they're all made available in the country. Otherwise, how do we have partnerships? Try to get the processing technologies, and establish the plants here and then process it here. Lastly, the market. What is the market requirement in the country? What is the market requirement abroad? And how do we meet this market requirement? And how do we see an industry which establishes? Finally, it has to come from an industry. And industry, the production, what it is going to do or it will be carrying out, has got a viability. This is another important thing what we need to. What I'm saying is, I think it is also, this point is touched upon by General Srivastav and Kalankuver also. Competing with the international market is very important. Country needs to have a policy in the material. Is one of the important things actually. That is where actually we have moved a paper and then try to see the preference for the indigenous manufacturing. Someone is making titanium here and titanium sponge related things and various alloys of titanium, or you talk about any other material. If there is an international agency which actually supplies it at a much lesser cost of 25%, whatever it is, how do we actually support the industry with this 25%? It's a policy matter. There are many measures in the government today which actually support this. In fact, that is one of the important things what in DRDO we have taken up. How do we support the indigenous industries in the material area is one of the important things across the departments we need to get and see that the indigenous manufacturer support it. Like the way now today, the government has got a policy below 200 crores you can't go outside is one thing. So it includes material also. So if there is somebody going to buy below 200 crores, he can't go out. But then we also need to look at if it is above 200, somebody is going to buy 1,000 crores or 2,000 crores material. How do we see that and how do the preference for this material can be given in the country? One of the important things. And in fact, we need to look at many places in the industry. Industry is ready to do many of these, take up these technologies and produce them. But the infrastructure, what is required in this industry is very, very important. That infrastructure we should be funded. That mechanism also need to be worked on. Talk about many technologies. I'm just talking about a very heavy press. Let's say 38,000 ton press, which is for the aero engines, various discs and all that today. The country doesn't have. But then there are interests shown by many people. So they may not be able to invest. So the infrastructure which is required, the machinery, equipment, what is required, yes, the departments collectively together can fund that, and then the industry starts using it and producing it sort of a thing. Another important aspect that we need to look at and support the industry. Coming to the materials, when you talk about it, there are some developments which have happened in the country. And there are some developments going on, but a lot more need to be. If you look at the DMRL, one of the important laboratories which works in this area, has developed many of the steels which are required for various applications, whether it is for the missiles, DMR 1700, or you talk about the steel which is required for ship applications, the steel what is now required for the submarines. All that have been developed in the country today. And that's how some of these areas we are able to say that the indigenous content in building these vessels is above 90%. So this is one important thing where we are done some activity and then which we need. But I've also concentrated on this certification process, how we can actually is very laborious, how we can actually shorten it and then see that we are not held up because of it. This is one of the important aspects which actually I'm myself looking into it, and we'll try to see how we can actually work on and try to see. And particularly this hardened steel is one of the important things which is required for armor vehicles, wherein you need to protect yourself. That's one technology where again DMRL is working and along with the associated. Now, coming to aluminum alloys is one area. where actually some amount of work with various industries have has gone in, a lot more to be done. And I actually should congratulate here Mithani and Nalco having come out with many technologies and also coming out with establishing a again one more industry in a joint venture for coming out with many aluminum alloys. This is one thing already they have already gone through all the approvals and things like that, and then they're about to establish that and the factory, which actually together they will be doing, and hope maybe in a year's time that should be able to come out with output of that. So if that comes out, I think many of the aluminum alloys related aspects we should be able to get it, and we should be able to. Then coming to tungsten is one thing. Yes, Immoral has done some good amount of work, and they're also establishing a good pilot plant, which I think they will be offering it on GOCO, that is government-owned company operated. Means the established infrastructure is the government, and the company operates mostly, I think, between DMRL and Mithani, and rightly said by Colonel Kuber that their sisters or brothers, whatever it is, and very closely working both organizations next door to each other and working together in this area and trying to do something. But lot more need to be done. Lot more need to be done. The armed forces people, particularly army, will be knowing that particularly when we talk about the in the ammunition, the penetration, when you say depth of penetration, the aluminum rod plays a very important role. Want higher DOPs. This is one technology what we need to develop in the country. That is one thing, another area related to that. Then coming to another important thing is the titaniums. This is one area where a lot of activity need to be done, particularly when we talk about aero engines. It plays a very important role, and a lot of work has gone in, a lot of work is going in, and a lot of industries are coming in. In fact, yesterday also had some discussions with a couple of industries trying to develop many things in this area. Titanium related alloys is one important thing which actually we need to concentrate, which we need to focus on related technologies also. In fact, there are a lot more things when you talk about aero engine, whether single crystal blades and various things, and turbine blades and related technologies is one more important thing what we need to create. And because the country is well determined today that aero engines need to be developed in the country, so we need to have all these technologies available in the country. That's one of the important things to look at. Another important one is the magnets, permanent magnets, and related other types of magnets, whether we talk about SM17 or SM15 or whatever or galadium type of material are required. Various things which I don't want to get into detail. A lot of experts are there. One area what we need to concentrate. The way now today, particularly the drones and UAVs and various technologies are coming, various motors, BLDC motors, whatnot, all required. The applications are tremendous, which we need to look at it and keep. And finally, another important area is people have mentioned again carbon fibers and ceramics and silicon carbide technologies, particularly for hypersonics and related areas. This is another important area what we need to get it. Whether we are talking about heads, airframes, all these technologies which are required is very, very important. And particularly talking about carbon fibers, high-end technology, I'm sure that the NAL is taking the lead and the NAL should be able to come out, and then we should establish that T800 and related technologies within the country. So these are beyond that, the actually semiconductor. That's another important area, very, very important area, which we need to develop in the country. Actually, some of the industry, R&D organizations and industry, whether it is CMAT, are talking about industry, the organizations like SSPL, these are all working. Whether we are talking about various semiconductor devices, talking about IR detectives, where you're talking about MCT or SCT and related technologies and all that, and materials, and the various wafers what are required to be produced in the country, and the substrates and other materials which are required for this, is one important area what we need to look into the country and to become ourselves. Because here again is one more thing what the country is focusing, that we need to have our own semiconductor fab. One is talking about various chips and whether we're talking about 25 nanometers or 15 nanometer to 14 nanometer technology or whatever it is, and the materials for it. Second, we are talking about various devices, gallium arsenide or gallium nitride devices, or as I said, various laser diodes, or we are talking about various other semiconductor diodes like impact diodes and all that. What is the material required and where is available, and are we making it, and what is the wafers required? This is another important thing. Lastly, one thing I want to mention, the manufacturing technology changing and getting more and more into the additive manufacturing. The various powders which are required for this, the metallic powders and related them available commercially in the country. Not become that tomorrow we land up in such a way that we are importing the additive manufacturing machines, and we are also importing the powder what is required for it, whatever the size it is. It should not be the case. We should work on it. This is where again I had some discussions with my Director General Dr. Kamath, who is actually a renowned man in this materials technology, and asked him to look into this particular area, and whether it is ARCI or other places or NML and all that, how we can see that these technologies are available commercially from industry. We need to get into this very quickly. Is another important aspect. So these are all the generic areas. I didn't want to get into more details here, and there are a lot more speakers and people from various organizations, including DRDO, and then you're talking about Methani or NAL and various other people there in that NFC. So we need to have a synergetic approach of various departments which actually get into these critical materials and evolve common strategy synergetically. What, how it will be put, what is the mechanism, how the industries, what are the support mechanisms we need to create. As I said, all these topics we need to sit together and come out with strategies, and the strategy as a whole nation should implement. And then the 5 years, 10 years, 15 years down the line will become self-sufficient and self-reliant. This, I once again actually congratulate very sincerely the organizers for taking this very important topic, very, very, very important topic for the nation. Congratulate you for taking this topic, and we need to work. We need to create the awareness in the country, across the departments and people who matter, and then take this forward. Thank you very much. All the best, and I wish this workshop our webinar is a great success. Thank you. Jai Hind. Namaskar.
Thank you. Thank you so much, Dr. Reddy. On behalf of IMR and CENJOWS, I thank you for your observations and insight from the very apex level. Most of what you have said is like it underscores very, very clearly the centrality of materials in the national security and growth and prosperity of the nation, whether it is the defense domain or even if it is the civilian domain. So, and you have highlighted a host of issues where it is important to have synergy, because cost effectiveness can only take place when we factor in cross-cutting usage, and as to how we can increase the market consumption by analyzing that if an industry house pitches in with X amount of money, for it to be viable, there has to be affordable, there has to be market inside the country. For that, we need to aggregate cross-cutting domains. That's a very important suggestion from your side. Also, sir, you mentioned that as far as procurements below 200 crores are concerned, The thing has already been put in place in DPEPP, but above 200 crores is also an area that we need to look at. We take note of that in our recommendations. We also flagged as to a host of measures which have been taken by DMRL, Midhani, NALCO, etc. NALCO and Midhani coming together, once again, a very good step in setting up their new project. So these are the pathways that can be examined by others too. As also you mentioned that DMRL is going to be going into a GOCO for tungsten. So this is a very path-breaking step indeed. A lot more needs to be done in those areas that you have flagged about magnets, carbon fibers, and especially semiconductors. Semiconductor industry, so the design is one part of it, and manufacture is the other part. So while our people are a good part of the design process, but we are not into the manufacture. So steps are being taken to get into that 14 nanometers. So again, heartening to know that silicon fabrication is what we are looking at. And your concluding remarks, once again, they underscore something that should be driving every effort, every sinew that all of us, all stakeholders will move to come together synergistically, because not just financially, but otherwise also to cut out infructuous work. We need to come together with the whole of a nation approach. So thank you so much, sir. And particularly your vision that you said that we should be looking at 50 years, 100 years from now. So that's the kind of vision that countries need to have. And you also mentioned that as to how United States identified 42 materials long back and they have made a strategy. So those are the models that we need to be examining. So thank you so much, sir, for your time and your remarks.